This video is for parts 1 and 2 of our Unit 5 Mid-Unit Skills Review practice assignment. So in part 1, we are working with 3 different forms of linear equations. Slope-intercept form, we know in slope-intercept form that is y equals mx plus b, where our slope is m, our y-intercept is b. In point slope form, we haven't really worked with that a lot in this unit, but we saw this first semester, so y equals m times x minus x sub 1 plus y sub 1. And in that form of our equation, x sub 1 comma y sub 1 is a point on the line that is not the y-intercept, or rather if it is, that will put us back in slope-intercept form. Finally, standard form is a form of the equation that we have talked about in this unit, and oftentimes this kind of comes up naturally when we're dealing with word problems or problems in context. So this is where we might see our linear equation look like ax plus by equals c, where from this form as it's written, we can't observe the y-intercept or the slope, but we can still find it. So, all right, in part 1, we are changing forms. So 1a, we have a function in slope-intercept form, and our goal is to change it to standard form. So this ax plus by equals c. So if I look at that, I want to get x and y on the same side. I want the coefficient of x to be positive, and I don't want there to be fractions. So lots of ways we could start this one, but honestly, if it were me, I like to deal with the fraction first. So if I have y equals 2/3 x minus 7, and I want to get rid of the fraction 2/3, well, there's a division by 3 there. So I can eliminate the fraction by just multiplying both sides of my equation by 3. We call that the multiplication property of equality. We learned that last semester. So 3y equals 2x minus 21. And now I want to get x and y on the same side. So I could subtract 2x from both sides, then I'll have to deal with the negative coefficient of 2. Or I could add 21 to both sides. So when I do that, I have like 3y plus 21 equals 2x. Then I could subtract 3y over. So I have 2x minus 3y equals 21. I also kind of flipped what was on each side of the equal sign there, and that's the reflexive property when we do that. Okay, so in standard form, 2x minus 3y equals 21. So we were asked to identify our slope, our y-intercept, and our x-intercept. And both of those we could observe more easily from the original slope-intercept form. So our slope is 2/3. Our y-intercept is the ordered pair 0, -7. Remember, our y-intercept occurs when x equals 0. So another way we could have gotten that was by substituting 0 for x. To find our x-intercept, that is where y equals 0. And so using either slope-intercept or standard form, we could substitute 0 for y. I'm going to use standard form because I don't want to deal with the fraction. So 2 times x minus 3 times 0 is 21. So 2x is 21. Divide both sides by 2. And I get x is, well, you could leave that 21 halves. I think that's what, 10.5. So our x-intercept is 21 halves or 10.5 comma 0. So let's get in the habit of writing those as ordered pairs. Okay, we haven't worked with functions or equations in point slope form really in this unit. But if I want to go from point slope form to slope intercept form, that is a skill we practiced heavily first semester. So essentially, y is already isolated. We just have to clean up the left-hand side. So I'm going to distribute the 6 to get rid of the parentheses. So y equals 6x minus 6. Bring down my constant plus 12. Then combine the like terms, -6 and +12. So y equals 6x plus 6. Okay, so identifying the slope, well, we could see the slope in both forms, right? In point slope form, our slope is that m that sits outside the parentheses. In slope-intercept form, it's the coefficient of x. So our slope, no matter how we slice it, is 6. Our y-intercept we can't see easily in point slope form unless we substitute in 0 for x there, right? But in our looking in our slope-intercept form, we can see our y-intercept. So our y-intercept is the ordered pair 0, 6. All right, lastly, our x-intercept. So again, you could really use either form, but I'm going to use the slope-intercept form. Our x-intercept always occurs when y equals 0. That's when we're at the x-axis. So if I just substitute 0 for y and solve for x, so I could subtract my 6 from both sides, I should get that x equals -1. So when x is -1, y is 0, and that is an x-intercept. Okay, last one for this part. For part C in standard form, we are asked to change the equation to slope-intercept form. So that means that we need to isolate y and get like everything on the other side of the equation cleaned up, right? Combine any like terms if needed. So let's take a look at this one. So if I want to isolate y, I could either start by subtracting 5x from both sides of this equation, or I could add 3y to both sides. It doesn't matter which you do. I'm going to subtract 5x. All right, so when we do that, now on the left-hand side, I have -3y, and I could either write my right-hand side as 15 minus 5x or -5x plus 15. That part doesn't really matter. And then now to isolate y, one more step, I want to divide my left hand and my right hand side of the equation by -3. And when we do that, we're dividing everything by -3. So -5 divided by -3, don't overthink it. That is just a fraction, positive 5/3. So the negative divided by the negative makes that a fraction. X is going to come along for the ride with us due to multiplication. Positive 15 divided by -3 is -5 there. So now we can see our slope. Our slope is 5/3. And our y-intercept is 0, -5. And to get our x-intercept, I need to substitute 0 for y and figure it out, right? I could do that in either form. I could do that in my slope-intercept form or standard form, but I personally think it is easier to do it in standard form, so I'm going to do it that way. So if I substitute 0 for y, I have 5x minus 3 times 0 equals 15. So if 5x equals 15, I could divide both sides by 5. X is 3. So 3, 0. All right, so to look at part 2, I'm not going to work all the problems out for the whole review, but I did want to go over 2 different ways of graphing. We know that when we're solving a system of linear equations, that we have a couple of options how we do it. We might use graphing, substitution, or elimination. And oftentimes when our equation is in standard form, we might really be wanting to not graph. But just a reminder that we can graph an equation in standard form 2 ways. We could actually graph all equations 2 ways, maybe more than 2, probably like a million ways, but 2 that come to mind. So in part 2, to me, what is an easy way to graph is to find the intercepts, if and only if the intercepts are integers. So if I get like 1.8 for my x-intercept, as we did in this unit, I'm probably gonna not graph that way. So for this first method, I would recommend finding the intercepts. So if I just find and plot the x and y intercepts, then I just draw a line between them using a straight edge. So if I want my y-intercept, that is where x is 0. So substitute 0 for x. We get negative 3y equals 6. Divide both sides by negative 3. And y equals negative 2. All right, so our y-intercept is the ordered pair 0, negative 2. And I'm going to plot that on our y-axis down here. So now to find the x-intercept, that is where y is 0 on the x-axis. So 2x minus 3 times 0 equals 6. That's the same as 2x equals 6. We get x equals 3. So the ordered pair 3, 0 is our x-intercept. And now we could just draw a line between those points. So if you're ever doing this method by graphing to solve a system, I would encourage you to use a ruler. I also, even if I start with just 2 points, oops, I went into the other graph a little bit. Even if I start with just 2 points, you could still check using the slope that the other points are on that line. Additionally, like the other method that you could have done if you hate finding the intercepts is you could isolate y, right? Like what we did up here, where we took an equation in standard form and rewrote it in slope-intercept form. You could do that and then use the slope and the y-intercept graph. So that's your other option. And, you know, whichever is preferred, they both work. For the second example, though, I think I would rather just graph this using the y-intercept and the slope, since it's already in slope-intercept form. So remember, if our slope is 1/4, I could think of that as rise over run. So for every 4 I move to the right, I rise 1. I could think of that as a unit rate. For every 1 unit I move to the right, I rise 1/4 of a unit. Probably easier to graph the first way. And our y-intercept is 0, 3. So remember, anytime we graph this way, we must plot our y-intercept first. Otherwise, from what point are we rising and running? It doesn't make sense. So I'm going to plot 0, 3 on the y-axis. And from there, we could rise up 1 and run over 1, 2, 3, 4. Conversely, you could also rise down 1. Seems like that should be called falling. Rise down 1 and run backwards 1, 2, 3, 4. And that still has a positive slope because it's a double negative. It's like -1 over -4. So graphing this line, again, you only need 2 points, but the more points, sometimes the more precise our graph. There we go. So this wasn't a system at the bottom, but if these two equations were a system, I'd want to lay them on top of each other, graphing. All right, so that is it for parts 1 and 2.